We live? Yes. Okay. So I think day six of Advent of Code. Um, Sorry for being late. I am going to try and read the question and understand it and get started. Um, for now, if you haven't read the question, you can always pause the screen and then read it. But basically, today's problem is um, after reading it, what I can see is a guard trying to walk on a two-dimensional map, and basically we have to follow the walk of the guard on the two-dimensional map until the guard is able to exit the map, and um, once they exit the map, we need to find out all the distinct positions on the map that they stepped on, and yeah, count the distance positions that they stepped on the map, and then that is going to be our solution for today. Positions will the guard visit before leaving the mapped area. Right, so basically in this example, using this as an example, there's a two-dimensional map. The guard starting position is over here, and you basically have two rules. Basically the guard just keeps moving in a straight direction. um yeah, so the starting position here is currently facing up from the perspective. So yeah, the direction that the guard is moving is always going to be marked by one of these, either an up, to indicate the guard is currently facing up from the perspective of the map. Any obstruction, which is these things, they are crates or chemical reactors or whatever, the hashes are obstacles. So long as the guard keep moving towards the obstacle, anything that is blank in their path, they are allowed to cross. So they will move all the way to this obstacle, and then once they get to this obstacle, the only rule is that they have to turn right 90 degrees. So they have to go into this direction until they meet the next obstacle. So once they meet the next obstacle, they have to come in this direction straight all the way down here, and then they meet this obstacle, and then they have to turn right again. Right, so they keep turning right 90 degrees until they meet the next obstacle. So you have to traverse again to this point, I think, and then turn right again, and then come straight down and go all the way left and come all the way here. Right, and this is the last obstacle, and then move all the way here and finally exit down here. Yeah, so I think it is shown here that this is the point of exit, and at the point of exit he was moving what down here. And after that, we just have to take note of every position that they stepped on and find out which of them are distinct. And basically, yeah, once we do that, we can count them and then print out the final answer. So without further ado, let me bring up my IDE and then start writing up a solution. Python. Okay, so this is the 6. Okay. Alright, so for the test case, as I always do, I'm going to copy over my test case, that the example that they used in the description as our test case. The expected answer is supposed to be 41, and the data looks something like this. and the data looks something like this. So let me put the data there, sample data for part 1, looks something like this, right? And I think, let me get the input for the problem of the day too, get a puzzle input. That's a big map. Okay, let me copy it and then put the data inside inputs.txt, right? So that's an even bigger map. So let me save that, close it, and close this, right? And then get to my solution, right? So to get started, I think the first things first that we need to do is clean up our data. Our data is always going to be, let's do a strip, and once the strip is done, basically it's a two-dimensional map, so we need to read it into a two-dimensional map, but we also need to find the starting position of the guard, right? So let's do it within here, starting position. Might do it in one line for is it always going to be in this format? Let me confirm. Control find carrots. Right, okay. Okay, so we're always on a starting position, but I don't want to know what that is. If the string carrot. Let's see. Alright, so we have to say the row dot index. Let's get the index of the carrots, and then once we are done, let's call it map. Okay. And I think that should be it for processing the data. Wait, what? Row number, column name. Okay, so it's looking pretty good. Yeah, it is looking pretty good. 9-4. All right, so I think we can start with our traversal. Yeah. So starting position and then direction. Turning 90 degrees left, I'm sorry, right, always just means um, if you're turning right and then you are moving up, the starting position, the direction will now be +1 and then keeping the x's. Yeah, it will now be +1 on the columns and then keeping the rows the same. So 0, 1, and if you are turning downwards, it will be -1, 0. Right, so let's do a map of the directions. If you have to turn right, I think I should probably just name them instead of just listing them like this. I should give them names, so that at least it is human readable to as well. Right. Is going to be no. I think the list was better. We all know turn right first means 0 here and then 1 there, and then turning down means -1 here. So let me order it. 0, 1, and then -1, 0, and then then 0, -1, and then the last bit will be 1, 0. Okay, so 1, 0 is going back up. Yeah. So 1, 0 will be the second position, like I'm not the last. And I'll put that here. Right. So we start by going up, and once we meet a crate, we turn right. And once we meet another crate, we turn right again. right? And turn right will mean going downwards, and once you turn right, you turn right again, which means going left. So you turn right, going right. You turn right again means going down. You turn right again means going left. Okay, this is the direction. And so we start from wherever the starting position is, um, and we are going to be using the index of the starting position. So we are going to start from, according to the test data, we probably starting from a position like 9 4. So let's do that. Um, so let's first start an infinite loop, and then we create a break when we get to the edge. So let me not call this position anymore. Let me just call it position. If position xy, if position is let me create a class that will help me do um, the position navigations very well. Let's call it post. It has an x and y component, and it also has a move function. Which takes in x and y components, a direction basically. And what it does is that it tries to add it and see if any of them is out of bounds of the map. Yeah, no. I'm just going to do it inline. I don't think it's that much of a deal. If position I'm adding the x component to the x component and the y component to the y component. Oh, okay. Yeah, so I'm adding the x components to the x component of the direction. I think direction should also be tuple of one of these. Since I didn't name them, I don't have to use the symbols. Or I could keep it and then keep their symbols. This is going to be upwards. This is going to be rightwards. And this is going to be downwards, I think. Wait, how do you present downwards? I have no idea. I have no idea how to. Oh, it's V. It's V. Uh, and how do you present backwards or leftwards? Is this okay? Okay. So if the next position is out of bounds, next position X, so the X, which is the row, is yeah, let's call it. Well, I can't be using the word map. Let's call it grid. Right? That's what they call it, right? Let me see what they called it here. It's a lab, so let's just call it like a lab map. Oh, great is perfect. Alright, so if we are in the bounds, then we are good to go. And the Y is inside. Right, so if we are moving out of bounds, then we can break. But if we are still within bounds, right, then we can see the next position is this. But before we move to the next position, we have to confirm that the position that we're about to move to is not a blocked position, like maybe it's not a hash, right? And so we need to check if next position is not equal to hash. We break to sorry, if grade dot get next position, if grade into brackets next position 0 and next position 1, right, is if it is a blocked position, what we can do is we can change the direction, right? Since this tick is already ordered and it gives the direction, we can just go to the next one. But yeah, we can just go to the next one of this. How do I alternate between these? Yeah, I can make it a generator. Right, I can make it a generator that's am I using this data? Yes. So I can make this into a generator that yields the next position, right? The next direction, sorry. So let's do that. Let's define takes in the direction and then that's one way to go about it. Yeah, I can just write if it is up, go right. If it is right, go down. If it is yeah. I really hate writing these statements, especially when they are like that plenty. But I guess I am going to have to write it. Okay, so direction was up. Yeah. So if we are going forward, sorry, it should be forward if we were going up, else it should be this, it should be left if we were going down. If we were going down, it should be left. If we were going down, yes. Or it should be up if we were going left. Or it should just be down, right? Yeah, down just means we're going right. Okay. So if we meet a crate, we should change our direction. And and continue. Right. If we meet a creed, instead of moving to the next position, we should change our direction and then continue. Right. And then we move here. Okay. And as we are doing all of these, we should just keep making sure that we are keeping track of the distinct positions that we visit, right? Yeah, the distinct positions that we visit. Okay, so let's put it here. Okay. Right. So I think that's about it. Let's put the starting position inside. The starting position was going to be the position that we are in. And why I need to do this, I do not know. And it can just be this. Okay. Right. If we move out of bounds, we do this, but until then, we keep doing that. Yes. And okay. I think that's about it for part one. Let's run the tests and see the outputs. Okay. I got 2 instead of 41. At least which is something. So let's see why. Let's see why we are getting just 2. Okay, so let me put a breakpoint right in this group. That's that. Okay. Okay, so it looks like we don't come back into the loop again. So let me run it again and then check this point if everything about this if statement makes sense. Right. So let me step into it. So the next position is 10 4. 10 4 10 4 10 4 10 4. Okay, that doesn't make any sense. That doesn't make any sense. That doesn't make any sense. Alright, so the position was 9 4. We are moving upwards. Upwards should be, oh crap. Upwards should be negative 1 0. Downwards rather should be 1 0. I think I see why now. So let me restart this. Then step into, right, 8 8 4 does make sense. Yeah, 8 4 does make sense. Oh, but why would 10 4 return? Hmm. 1 2 3 4 5 6 7. Starting position is 7. Why does the start position here say 9? Why does starting position here say 9? What am I doing wrong in the original data? Nine. I think maybe I should just first of all put a breakpoint here, right? And restart. Okay, let me see what row is. Is this the first row? Yeah, that is the first row. That looks like the first row. Okay. That is it. Oh, because I did not stop the loop. Yes, I did not stop the loop, so it doesn't know where my row was. Okay, so 4 6 that makes sense now. And then now we can start traversing. Okay, it's looking good now. So I can take away my breakpoint and then just let it run wild. Part 1 says 43. Okay, so something extra. Okay, let's get back to it and do some analysis again. Okay, so it's clearly moving in the right direction, so it knows to be going up. We started from 4 4, and then we are moving to 5 4 4 6. Wait, what? I'm supposed to be going up, right? Yeah, I'm supposed to be going up. Then my position is 6 4. And so when I move up, it should be 5 4. I think, yes, it should be 5 4. Oh, I forgot that. Um, yeah. So when you give a parameter to the set variable, it unpacks it. So it was entering the values 4 and 6 as values in a set instead of the tuple 4, 6. Alright. Okay, so I think we are good now. I think. Oh no, I have to make it this way. I think. How do I think I should go the direction that he was trying to. Yeah, this definitely should put a tuple in there. This definitely should put a tuple in there. Okay, good. And then next becomes 5 4, and next becomes 4 4, and 3 4. Go all the way to 2. Then realize you have the 10, so you 10. Right, 1 4, and then you 10. Right, good. And once you 10, start going to, yeah, 1 5 now. So it's all moving right. Okay, so I think this looks good. I can turn this one off and then run this. Then now I should have my test results. Where's test one? Okay, so one pass. Where is the results? Okay, pass one of two tests, and test failure is, so the test two is failure, which means my part one is ready to be submitted. So I can run the part one to see the results 5095. Let's put this into the solution and submit. Great, we have one gold star, and let's go straight into the part two. Okay, so part two, I'm going to keep quiet again and read it, and you can always pause it and read it along too as well. Okay, so six situations use zero to mount any obstructions. This to show position where the guard moves up or down, and this to show the position where the guard moves left or right, and plus to show a position where the guard moves both up, down, and right. So what is an intersection? Option one, put a printing press next to the guard's starting position. Put a stack of failed suits. Put a stack of failed suit prototypes in the bottom right quadrant of the map. Okay, right. Right, and option two is if we put it down here, then he will be forced to move into this direction again. Okay, so we can right, right, right. Option three, you can put it bottom right quadrant. Okay, we can put it there, and then that will mean that they are once they come in this direction, once they enter this, they are never leaving because now they are stuck in this loop. Okay, option four, put an retro encabulator near the bottom left. Right. So on here we they are stuck here. Yes, to me they are stuck here. Option five, there are so many options, right? A bit to the right. Yeah. Oh, okay. This is big. Option six, put a tank of the sovereign blue right next to tank of the universal solvent. Basically at the exits, just prevents them from exiting, and then you can. It doesn't really matter what you choose to use an obstacle, so long as you and the historians can put it into positions without the guard noticing. The important thing is having enough options that you can find one that minimizes time paradoxes. And this example that minimizes, there are six different positions you could minimize time paradoxes. So the minimum loops that you can find, you need to get the guard stuck in a loop by adding a single new obstruction. How many new? Okay, now this is very interesting. So basically now the guard going around the lab, we are trying to trap them in forever, in a loop, but we can't just put it at a certain position, right? We have to put it in a position where the guard won't notice. So you can put it at a certain position because the guard is right there, so he would know if you place it right beside him. So yeah, it has to be in a position apart from the surrounding positions to the guard. And yeah, and if you place it right next to the guard like that, so I thought you said we can't do that. No, we can't put it in the position, but we can place it next to the position. Okay, right. So we can place it anywhere on the grid except the certain position itself, and the guard will be caught in a loop. And in this example, there are six different ways to get stuck in a loop. Okay. I really don't like problems like this. Problems that the solution looks like an open-ended solution. Firstly, there are pretty sure adding a single new obstruction won't cause a time paradox. They'd like to place the new obstruction so that the guard will get stuck in a loop. Like to know all the possible. The new obstruction. Okay. So basically, we have to find all the possible ways we can catch this guard in a loop going around in the grid. And yeah, so basically, once we have gone through all the cycles, we can put a block there as one, and then yeah, I think I have the idea. Yeah, basically, once we complete a cycle, we can just put a block at that position, and same thing for this one too, right? Yeah, yeah. Once we revisit a position that we are in, and that we were once in, and um, we have gone through all four cycles, we can just put a block there, and it will create a loop. And same thing for here. Let me see as we keep going. Right, as we keep going here, and there, and there, and there. Once we get to a position where we've already visited, right? Yeah, once we get to a position that we have already visited, and we have been through all four, so let's just say hmm, hmm. Okay. Yeah, so I think I get the idea. Yeah. Once we yeah. So the idea basically is that we can go through the grid like so, right? And once we encounter any position, like once we, so there are going to be four different directions. That's the guard can go. They can go up, right, down, and then left. And once that cycle has been completed, right? Once every time the cycle gets completed, we can just put a block at where it's going to get completed, and then it means they have to like keep in that loop, right? And we can keep doing that for all the various um, completion of cycles, and then we will get um, all the possible ways we can catch this guard in a loop. So let's put the example here. Since they both use the same example, I'm going to put it here, and let's start writing the solution for part 2. So in part 2, as we are using the same data, let's get the grid out, and data dots get map, and position, start position is that, starting direction is definitely going to be that, and direction is, yeah, direction is still haven't changed. It's still up, right, down, and then left, and yeah. Mhm. Um, and I think for the start we are moving upwards. Make this step. Okay, we need to find a name for what we are going to call this then. Okay, so what we need to define is obstacle positions. Which is going to be a list, not necessarily a set. Yeah, I think that makes sense. Yeah, I do think that makes sense. We'll just keep continuing. Okay. Yeah. So we need to keep track of the visited ones, but we'll be clearing it. And we need to be keeping track of the directions too, because we'll be clearing it too as well. Okay, so we need to keep track of visited positions. And we also need to keep track of, because we'll be clearing it, and we need to be keeping track of the direction loop, direction sets. Let's call it direction loop, and it's going to be a list of the directions that they have used when they visited all the positions that they're going to visit. Okay, so let's start traversing the grid now. Same thing as we did before. We're going to get the next position, and we're going to traverse it. And if we are out of bounds, this time if we are out of bounds, we don't break. We just put yeah, I think we are going to break too, but before we break, we have to do put an obstacle inside there first. Wait, if the next position is out of bounds, so it should be positioned. Okay. We don't need to set this if we are going out of bounds. Okay. Okay, so let's start. Let's start by also doing this bit too is also going to be repeated. Basically saying if we encounter an obstacle, we have to change direction. Right. So now there comes the important to this problem, right? We have to just keep track of when we complete a full loop, and a full loop is basically a direction set of up, down, left, and right. So once we have all the four, we can set it, and then we can reset the direction loop and put the new direction inside the loop. So we can say if whenever we change direction, we say direction loop dot append, direction. Yeah, once you get all four, you can reset it. Alright, and let's start from 1 now. Alright, and once you get to 4, you have to place an obstacle, right? So once you get to 4, you must place an obstacle at your current position, but not immediately when you get to 4. Once you get to 4, and then you get to a position where you have previously visited. Yeah. And the position is a position that you have already visited. And position is in yeah, you can reset this, and then obstacle positions will now be next position, right? Yeah. Okay, and so once you can do this, you can how do you call it? Yeah, I think this makes some sense so far. Right, so yeah, once you complete a loop and you are in a position that you've already invested before, then it means you can reset the directions, and then to just see this direction now, and you just keep going, right? Yeah, you keep everything apart from yeah. I need to reset the visited. Yeah, I need to reset the visited in this direction. whenever the direction changes, we have to reset this. And whenever you complete a loop, you have to use the visited indirection to replace visited now, because now you are starting to look for a new loop, right? So no. Right, and this will make sure that the place that you visited becomes, I think that's about right. And then the only thing that we are interested in at the end is the obstacle positions. So we return length of obstacle positions, and we are true. Okay, so now let's put sample data in test2, and then go test2 now. Test2 is supposed to be 6, I think. Let me confirm. Right, it's supposed to be 6 here. Okay, let's run this test now. Okay, my loop seems to be running forever on test2. Okay, so I am definitely caught in some while loop there. Okay, let's look at the conditions again. So next position is calculate the next position, right, based on the direction that you're already going in. Move right if we were going up, move left if we were going down, move up if we were going left, and move down otherwise. Okay, so it seems this block is never getting entered. I'm guessing the grid reporting the position. The grid get used, and yes, the grid gets used over here, and the grid gets used over here and here. Oh, and then the column are out of bounds. Then you can break it. This one says if. Yeah, so why is this never getting entered? I thought, or is the direction never getting changed if we meet a hash, right? Then the direction should be changed. Okay. Okay. My initial analysis shows that everything is sensible so far. So let me put some breakpoints in the loop and see how the loop is behaving, right? I want to know whenever we change direction. I want to know whenever we complete a cycle. And yeah, I want to know when it is time to break. Okay, let's run this again. Did I change anything in part one? No, I didn't. Didn't, right? It says list index out of range. Line 12. Line 24. Hmm? Did I cut it? Oh my goodness. Okay, so the part 2 seems to be caught in some sort of loop already, which isn't very good. What is going on? What is going on? Okay. My test case. I'm in the bag mode. Okay. Right. So the loop is started. None of it gets entered. We have been changed directions. We have been gone out of bounds. We are just moving. Oh, right. Okay. Okay, let me compare something from here. Right, yeah. We are doing left now, and then next we have to do hmm. Okay, I have seen my first mistake. Direction loop should start from here because we only append the directions when we change direction. So the starting position should always involve direction. Okay, so now we await. Yes, now we finally have our starting position set to 6 7. Let's see, 6 7. Does 6 7 make sense? What is it? Data 0 1 2 3 4 0 1 2 3 4 5 6 0 1 2 3. No, 7 doesn't make sense. 7 doesn't make sense. Yes, 7 doesn't make sense. Why is it saying 7? Why is it saying 7? Alright, so I was moving in this direction. Hmm? Up is this, right is this, down is this, is plus, and left is -1. Why does it say 8? Not why does it say? Why does it say 8? It shouldn't say 8. Oh, because I said right. Let me see the grid again. No, it shouldn't be using position. It should be using next position, right? Because my position obviously is already inside the grid because it was added in there, right? Yeah. Okay, how about, putting the next position. So over here we are putting the next position inside the place that we have visited, right? What do I need to do to fix this? I need to not put it in visited until we have actually visited it. Mm-hmm. I think this should be a fix. Right. When I start moving left, I shouldn't enter until I get all the way to 6-5. Yeah. 6-4. That makes sense. Okay, 6-3. That makes sense. Let's see. 6-0-1-2-3. Yeah, that does make sense. Okay, and then we can continue with our looping. Okay, now we've completed a new set of 4. So in the second one, I am going down, I think. Okay, yeah. This is the first one, and the second one. If I counted this, I haven't done that, and I'm going down. And then once I get to this position, I must put 1 here. Let's see. Right. And 7-6. Let's see where 7-6 is, if it makes sense. In there, from the browser, let's go to 0, 1, 2, 3, 4, 5, 6, 7. 0, 1, 2, 3, 4, 5, 6. Yeah, that seems to make sense. Okay, so let's let this run out and let's look at the output. It says 4 isn't 6. Okay, so I was able to find 4. Let's see which ones I couldn't find. Tests, solution, to breakpoint whenever I am adding stuff to the obstacle. Okay, and then let's run this 6-3-7-6. The next one should be 6376. The next one should be, let's run down. So I keep running down. I keep going, right? Yeah, going down, then left, and then up, and right again. When I discovered this, I was going down. I was going down when I discovered this. This one is ours. Okay, one is 7-7. Now I was going in this direction. 7-7, and I was going in this direction. Okay, that makes sense. And then the next one is going to be, it's supposed to be, the next one is supposed to be at, when I hit this, where do I go? I go up, right? So yes, so I go up now, and then oh, I've only covered half of the cases. Alright, so there are other cases where I could put them at, and those cases are I think I've already captured this. I didn't capture 4 and 5. So case 4, how were they able to get case 4? Okay. Oh, you could place one right before you hit. How am I supposed to figure that out? That's incredibly difficult. Case 4 has no logic to it as to how they were able to figure out. Let me think for a minute. Wait, go here, come here, go here, come here, go here, come here, go here, all the way here. Create a loop. Right, create a loop down here. Saying if I should stop you here, cause you to go all the way up here. You would have, god damn, god damn. Now that's a very tricky situation. That is a very tricky situation. So now I have to basically um, find a grid. I should put one here, then you're forced to turn here. I was able to know it. I was able to know that by knowing that if it's up, right, left, left, down. I can't think of a way to solve this part too. I just can't think of a way to solve this part too. I can't seem to figure out how. I mean, as a human, I can understand that visually you can see that as you are moving along this direction, so that if you put a block here, force it to go up, then he will join this group here. Right. Yeah, I think we should be looking for squares. Right? Bounded squares. Mm-hmm. Yeah. Okay. Basically, I was going in this direction. Okay, so I think maybe if we keep track of the position visited along with the direction that we were going when we visited that position, we will be able to know when a square is formed, a perfect square is formed, right? Or like a perfect rectangle is formed. And then yeah, perfect rectangle is when you have 1, 2, 3, 4. That's going to be a lot of checks if you're going in this direction, somehow you're crossing this direction. Oh crap. Oh crap, oh crap, oh crap, oh crap, oh crap. A square can be formed up here. Let me look at this. Yeah. Once your work gets completed, you can look for when once the loop gets completed, you can look for when, for instance, you are in a position where you've already been. That's one way. Or the position that you are on, when you close it up, it forms a square with the positions that you have already been on. Right? So instead of just checking for this, you cannot check for if closing it up on the next position, causing it to go up would create a perfect square, right? Same thing for here. If closing it up over here, I think we were going in this direction, so if closing it up over here would force you to have this. Yeah, I think I have the idea now. Okay, so this is one condition. The other condition is to check if closing it on the next position, right? Let's call it is direction loop. And it takes in the next position. No, it takes in the current position, and it takes in the direction, and it takes in the visited. if it does, then we basically do the same thing. We just put an obstacle in the next position. And we let it know that you have to keep going in that direction, and the visited list still doesn't change. So just this. So let's define this function here. Control V. Action. Create function is direction loop. Okay. Yeah. So this is going to basically check if so I need to capture situation 4 and 5, right? And situation 4 and 5 is when you are on some path that previously that path has formed some form of an uncompleted grid, so you need to like forcefully close it to make it a grid. And how we are going to determine that is we are going to have a list of all the visited paths and the direction that we are currently going on, and the position that we are currently on to as well. So if the position is in visited, and as at this point that we are querying this, we know that we already have a direction loop completed, right? We just don't have a right. So we need to check if we are going in this direction. We look for says visited, doesn't say the direction that we were in when we visited it. Right. Okay, so I need to keep track of that data. Yeah, so I need to keep track of visited. Okay. So either this or I modify the grid itself, right? Yeah, let's modify the grid itself. Let's modify the grid itself. Yeah, let's call this one visited in cycle. In that case, I can have visited keep track of both the direction and then the yeah. Okay, so I think the best thing to do would be to modify the grid as we traverse it, right? And so basically saying if okay, so let's do that. um Whenever we visit something, we want to modify the grid, we say grid into brackets, position 0, position 1 should now be equal to if direction is equal to up or down, right? Else use this. And the grid position is a dot, use this. If we are going down, direction down or up, if you are going down or up and it's a dot, use this, else use that. Right, so if we are in Okay, so let's make this one return false, and nothing would have changed, and I can run the code. Right. They are still strings, so I need to I need to split it into a list, basically. If I just put a list on a string, what happens? Right. Okay. So I can just do that. Okay. Okay. So I think everything is working as usual, except we haven't defined this. We haven't defined this, but yeah. So let's try and define this part. And we have to pass in the grid too as well. Yeah. But first, let's have a look at the grid whenever we pass over it. Right. Okay. So to have a look at the grid, let's that is wrong. Should be this. Right. So it should be up or down if yeah. Well, let me have a look at the map again. This is incredibly incredibly tricky. Um, You could actually just put one here, and it will mean that, okay, you can't, because, right, because this one is imaginary. Okay, I think I get it now. This one technically is a plus, right? No, this one technically is a plus, so you have to stay in the cycle. This is not the cycle. I think you have to stay in the cycle because this. Yeah, the problem you have to stay in the cycle. Yeah, so that will work. Right, that would work. I just need to sort this one out. It should be hyphen if um, if we are going in this direction, it should be, and it's a dot, it should be that. As a dot, it should be that. Right? If you're going in any other directions and it's I'll just use plus. Okay, okay. I should probably just write it down differently. Now, if it was, yeah, up or down, use a plus, and yeah, if it's a plus, just leave it as is. Um, yeah, yeah. Let's see how this one looks like. Okay, I want to see how this looks like. I just want to see how this grid looks like. Go. Okay. Right. So I think I've gotten the classes correct now. So let me focus on building the function is direction loop. So a direction loop is going to return true if we have a completed direction loop, of course, and and when we forcefully close it at the next position, the position that we are at, yeah, we forcefully close it at the position that we are at. Um, the direction that we are going in. We can get a full 360, right? So we will look inside the visited positions of the grid and check. We will look inside the visited positions of the grid, right? And then check. See if when we close it, then check to see if there is a plus at the very top of where we are at, right? So if there's a plus at the very top of where we are at, let's see. Right, so if which means the column section keeps changing, right? So we look for row, so check the positions there. What column are we at? We keep changing. columns, then we have to check if the row is inside the visited. So we have to check if position 0 so anything. Alright, so we are going to check if a row and column in the visited, if there is this row somewhere in there. The column somewhere in there, sorry. If this is in there and right, sorry, if the column that we are currently on is somehow on and grid row colon somehow is equal to is equal to plus. Okay, so if I'm going in this direction and then I see a visited up here, and I see a visited up here which is a plus, it's most likely here. Okay, so we return true. Same column as you. Yeah, the same column as you. You can tell that when you close it here. Nice. If the position is 0 and it's go to row, and then yes. So yeah, you have your conditions. And let's run this again. Okay, I got 7. Just interesting. Let's try and find out where those 7 are. I want to specifically know when these are getting populated, right? Ooh. Okay, so obviously I am going in this direction. I have for the first one. Hmm. Complete the direction loop, and then I get back to a position I have set before. Close it. Or if it is close in the direction loop, that's what this is checking. Position 6, 8. Direction is this. Okay, so let's look at it. Alright, it stinks. So just like I was expecting, right, I should be using the next position instead of yeah. I see what the problem is. It should be the next position rather. shouldn't this one be next position plus 1? Because in here you've changed the direction already. Right, you've changed the direction over here, and you've instead of visited in direction, but the position is still the old one. Right, so the position still hasn't changed. The position is still the old one, clearly. The next position is a hash. Markets. I move on to the next position. So we change the direction, marked it. So this position is listed. Then we continue. The next position has been calculated. Right. Yeah. Let's do that. Next position. And then over here, instead of putting the next position down as the closing one, we can put the next position plus the direction. Okay. It's obstacles. Still getting 7, which means my changes didn't necessarily work. If you are going in this direction, then you find every position that matches the column. matches the column, and once you find that, you can check to see if the grid if the grid the grid rule the grid rule is a pass. The grid rule and column. Okay. I think I need to debug this function very well. First of all, it shouldn't be stepping inside this so soon. Okay, so now we are going in this direction. We found a grid. Yeah, that's a grid. Okay, so I think I am making a big error here. Come. All right. The last thing to do would be to check. Was if this direction low? Okay, let me take out this again. And then you are back on the place where you visited. And then you're back on the place where you visited. Then it should be closing it. But if you're not, and then there is something up there. Just edit and exposition crosses out. It should mark it. So that's what it did. I wanted to see if the correct position marks out. sure. Yeah, whenever you change direction. This should appear before this, and this here we can check if the just change direction. We just change direction and we are now coming in. Right. Since we are now coming in, the next position. Okay. This one is saying if the next position closes out. Okay, this will probably be enough. I just need to make this one a set. The obstacle ups a set, right? And add to it instead. Right, and that should do the trick. I think because these two are now competing there. The four are now competing. Okay, so we have a happy place to be. Whew, that was tough. Let's find a solution. I'm sorry, what? 2, and 2, that can't be right. uh, and so okay. So it kind of looks like 2. Does that even make sense? If that small grid is giving me, how is that 2? So complete side exit. I doubt it is the answer, but let me for okay. Now let me figure out how it was able to arrive at 2. Right. Okay, let me first get back to the test cases and then pause it right here and be sure it captures positions 4 and 5. Oh Christ. And be sure it captures position 4 and 5. So to ensure it captures position 4 and 5, option 4 and 5, sorry. Obstacle position, right? So this is the set I'm interested in. And we've captured our first one, so cool. 6-3, 6-4, pretty standard. 6-3, yeah, 6-3. 60 was supposed to be in there. Wait, what? This grid doesn't look right. What I'm looking at is this grid. So we start out from here, I think. Here, yes. We move all the way here. We turn right, we come down, keep going down. We get here, we turn. And that's a 60. Which is cool. Right? Zero, 1, 2, 3. And then when we go up and right and down again. One, two. But it then continues and says, what is this one down here? Right. So when I move on to the next one, it will say it will this is incredibly difficult. Should say that I have been here. I'm really thinking deep about this. Um, before and then it's also a plus. How have I managed to block myself in the loop? No, this is not right. Three, 6. I heavily doubt that. 1, 2, 3, 4, 5, 6, 7. Yeah. That can be right. later. Okay, so let's see this. Let's see what's going on. Let's see what's going on here. 6 7 6 3 5 6 7 6 7 2 7 7 9 7. 6 7 6 3 5 6 7 6. Let's look at these numbers first. Why is it so persistent on getting things on position 6? Right? Yeah, because okay, 9 7 is there. It's supposed to be 2 from 8. Nothing is there. 2 from 7 and 1 from 6. I'm going up or down, and the position. And then I find a row in the visited pools, which matches my Alright, so we started out here, we went all the way here. Okay, so it shouldn't check until we have moved, right? So the position is not visited, but check it. I want it to not check because we just switched directions. We just switched directions when we moved to that directions. What if I do check with the next post instead? Next position instead. Okay, this one will be next post plus 1. Okay. So this means that this needs to happen before so 1, 2, 3. So I'll put down 6, 3. Right, then the next time, which means I'm going to come here, and this should put down 6, 3 again. Good. So that is why we made it a set. Yeah, that's double state to this direction. history. So which one is about to put down now? I think it's about to put 7-6 down. 7-6. Where is 7-6? Yeah, this is 7-6. And I think this should continue. They should also put down 7-6. I see what's going on. Next time is 7-7. Okay, 7-7 is also captured, and then I think the other one will also try and capture 7-7 again. Okay, so 7-7 has been captured. Once you hit this, you must go down. Right? This was never captured. And it was going in this direction. Oh crap. It's going in this direction. Oh crap. which means I'm not supposed to reset. Okay, there is no need to reset this at this point. I think this reset is not important, right? And I think this reset is not important. Trying to control find. Yeah, once you find it, just try and actually see if it makes a square. Once you find a one, just right. So I think since this microphone is probably going to die, what I can do is change my microphone to this one. Yeah, my microphone is definitely dead. Yeah, so I think yeah, we do not need to reset it. You just need to check for the actual square. Wow, the actual square within the grid. Okay, so if once you found a matching left side, you try to see if there's a matching right side. So there could be a plus, or there could be a plus, or there could be a plus, right? So once I get a matching closing edge, I should just look for the other edges. So on the, if we are going in this direction, then we can look at the column, right? So we check the visited. Oh God, what am I doing? Then on that row, right? Then on the row of this, oh boy. We're already in a cycle. So doing that will just capture it, wouldn't it? I don't need to do anything else. We're already in a cycle. I think I should just take out the repetitions. Okay, let's run it again. Okay. Now it is looking more sensible. 737. No, not sensible at all. Nice 7. Okay, I'm going to close the stream now and then give it another try later because I'm probably missing something very simple here. Alright, so I'll catch you again.